Friends, we're going to do some solving of exponential equations. Really there's 4 different types of you might see. So let's start with some kind of simpler ones. If you just got exponents on one side of the equation, well, all you've got to do is translate this into a logarithmic equation. Okay, the base becomes the base, the exponent becomes the logarithm. And you just stick that in your calculator like that. Change the base theorem is the easiest way to do it. Log 5 divided by log 2, and you get this answer, 2.322. Same thing here. Alright, rewrite it in logarithmic form. Stick that in your calculator like that, and get 0.481. You'll notice here you can do a log base 10 or you can do natural log, ln. Okay, it doesn't matter. You can change the base to anything you want, but your calculator will do log base 10 or log base e, natural log. Okay, so exponents on one side make it into a logarithmic function, logarithmic equation. If you got exponents on both sides but the same base, this is the easiest one. Right? 2 to the power x equals 2 to the power 7, so x equals 7. That's it. 3 to the power something equals 3 to the power something, so something equals something. Add x, subtract x from both sides, add 1 to both sides, x equals 3. Now, you might see some people in some textbooks, some websites, some videos say you have to do an extra step in here. You have to take logs of both sides. Okay, and then use the power rule. So the power comes down the front, and then log 2 and log 2, that you just divide by the number, log 2. Well, that's great. You can do that if you want, but you don't have to do that. The reason I point that out here is that in the next 2 methods, taking logs of both sides will be a helpful thing. Now we've got exponents on both sides. It's not the same base, but it's a related base, right? They somehow have a common factor, or they're both powers of the same common base. So what we do is we write them in terms of a common base. So 4 is 2 to the power 2. So 4 to the power 7 is 2 to the power 14. X equals 14. Same thing here. Well, 81 and 27, what do they have in common? They're both powers of 3, so we rewrite them as powers of 3. You probably do this step in your head, where you multiply out the powers. If the powers are the same, the bases are the same, then the exponents are the same. So these exponents are the same. Take away 4x, add 3, and then divide by 2. Okay, that's the easy ones done. Okay, these can be slightly harder depending on what you use as your bases up here. But now we get to something interesting. Now we get to the bases are not the same. And I'm going to give you 3 examples of this. The bases are not the same, so what we have to do is take logs of both sides. Now you can take log with any base. We'll just keep it a log for now, and I'll tell you something in a second. So we use that power rule, the third rule you've probably learnt, where you take the power down the front. So x plus 5 log 2 equals x minus 2 log 3. Now here's the decision-making process. You can leave it as log base 10. You can make it natural log. Or I think the smartest thing to do is here, pick one of these. Pick 2 or 3. I'm going to pick 2. I'm going to make the base 2. Really, this is what I've done at this second step here, but I just waited a while to do it. I'm going to make this log base 2. What that does is that log base 2 of 2 is 0. Is 1. So, and log base 2 of 3 is 1.58. So we've just got one crazy number. We get rid of this crazy number and just end up with 1. Then you just expand the brackets, do some simplification, get your answer. So a bit of calculator work going on here, but that's all you do. So choosing what base to do makes it easier. So in this case, I would choose base 2 or base 3. Here's another example. So once again, I take logs of both sides and take the powers out the front. Now, again, you could leave it as log base 10 like it is here. You can make a log base 9 or log base 4. Some books will tell you do it in terms of natural log. And sometimes some questions will tell you to do that so that you can do some simplification. If they say leave it in exact form, like don't use a calculator, maybe ln is easy. So you'll expand out the brackets, you get all the x's on one side, take out x as a common factor. You notice here where it says 2 ln 4, let's make that ln 4 to the power 2. And you could do that, and so that would be your exact answer. And you stick that in your calculator, you get this, negative 8.16. Okay, so some books will encourage you to do that. I don't think that's the best idea. I'll go back to this step, and I would change that to log base 4. Why do I choose 4 instead of 9? Well, because this 5x plus 2 is a bit more complicated than the 3x. So get rid of the complicated side. Alright, so log base 4 of 4 is 1. Log base 4 of 9 is 1.585. And just do some simple math there, simple algebra, you get your answer. Okay, so I really encourage you to think about, pick a base, take logs of both sides. That base can be any base, but pick a base that makes sense. Sometimes it's 10, sometimes it's e, most of the times it's related to the base of what your original questions are in. Okay, one more example. Here we've got 6 and 2, right? Nothing in common, so I have to take logs of both sides, take the powers down the front. Alright, now we decide what base are we going to use. I think I'm going to use log base 2 because 7x plus 3 is a bit more complicated than x minus 5. I want to try and end up with positive numbers if I can, and that might get me there. So yeah, I've got 7x on this side and 2.585x on this side. So I'll just simplify that a bit and then divide out. Divide out. Okay, so that's how you solve exponential equations. If you've got exponents on one side, it's write it in logarithmic form. If you've got exponents on two sides, look for anything common. If there's nothing common, take logs on both sides. All right, good luck with these questions.